Welcome to JavaScript Pro, the comprehensive course designed to take you from intermediate to advanced level JavaScript. JavaScript is everywhere. From dynamic websites to mobile apps, mastering it is the key to unlocking opportunities as a developer. This isn't just another JavaScript course, it's a step-by-step guide into the features of the JavaScript language. This course is for developers looking to level up their skills. What truly sets this course apart is our teaching style. I use the active recall technique popularized by Cal Newport, the author of Deep Work and a computer science professor. This technique engages your brain in a way that helps you truly internalize concepts by actively practicing how to retrieve them from memory. In every section, you'll encounter carefully crafted study questions, designed not just to teach, but also to challenge you. We'll go over a possible answer for every single question, helping you fill in any gaps of your understanding. Plus, there's an accompanying eBook and PDF that includes all the questions and answers, so you can review and reinforce your knowledge anytime. This course is designed to actively engage all learning styles, visual, auditory, reading, and kinesthetic, so that no matter how you learn best, you'll find an approach that works for you. Every lesson is structured to utilize multiple senses and areas of the brain to maximize retention and understanding. We start with the fundamentals of advanced JavaScript, covering object-oriented programming, prototypes, ES6 classes, and modules. You'll dive into practical tools like Babel, Webpack, and Node.js to build projects that mirror real-world scenarios. My goal is to teach you how to think like a professional developer. By the end of this course, you'll have the skills, confidence, and mindset needed to tackle complex JavaScript problems, ace job interviews, and have the fundamental programming skills needed to build apps. So let's go over what you'll learn in the 9 sections of JavaScript Pro. Intro to Advanced Topics. We start with the essentials, an introduction to advanced JavaScript concepts, and how this course is structured to maximize your learning. You'll set up a professional development environment and gain an overview of the key skills you'll develop throughout the course. This section lays the foundation for a smooth, productive learning experience. Objects. Master the core principles of object-oriented programming, also referred to as OOP, including the 4 pillars, which are encapsulation, inheritance, abstraction, and polymorphism. You'll learn how to create and manipulate objects using different approaches like object literals, factories, and constructors. By the end of this section, you'll understand how to manage properties, use getters and setters, and handle concepts like abstraction and private properties, which are all critical for building scalable and maintainable code. Prototypes. Discover how JavaScript's prototypical inheritance works under the hood. Explore key concepts like inheritance, property descriptors, and the difference between prototype and instance members. You'll also learn when and why to avoid extending built-in objects and how to iterate through prototype members effectively. Prototypical inheritance. Build on the previous section with a deep dive into creating and managing your own prototypical inheritance hierarchies. You'll learn how to reset constructors, call superconstructors, override methods, and even implement polymorphism. By the end of this section, you'll know how and when to use inheritance in real-world projects and how to enhance functionality with mixins. ES6 classes. Transition from traditional prototypes to modern ES6 classes. This section covers class syntax, inheritance, and static methods. You'll also dive into advanced topics like using symbols and weak maps for private members, hoisting, and method overriding. These are the tools that will make your JavaScript cleaner, more maintainable, and align with modern best practices. ES6 tooling. Master the tools that power modern JavaScript development. You'll learn how to use modules, both CommonJS and ES6, as well as how to optimize your workflow with Babel and Webpack. These tools will allow you to write cleaner, more efficient code and ensure compatibility across different environments, which is a must-have for professional developers. Node Module System. Get started with Node.js and understand how it enables JavaScript to run on servers. You'll explore Node.js architecture, the module system, and key built-in modules like path, OS, file system, and events. By the end of this section, you'll know the fundamentals of Node.js required to create powerful, scalable backend systems and understand how the module wrapper function and event-driven architecture work. Node Package Manager. Learn how to manage project dependencies like a pro. This section covers everything from creating and managing package.json files to installing, updating, and publishing packages. You'll also explore semantic versioning and best practices for working with global and local packages. These skills are crucial for maintaining efficient, collaborative development workflows. Asynchronous JavaScript. In this section, we will cover one of the most important aspects of JavaScript, asynchronous programming. Learn the difference between synchronous and asynchronous code and how to manage async operations using callbacks, promises, and async await. You'll also explore patterns for handling callback how, running promises in parallel, and creating subtle promises. This section will give you the confidence to write efficient, non-blocking code for real-world applications. So how can this structure work for you? Each section is designed to build in the laughs, creating a seamless learning journey that connects theoretical knowledge with practical applications. Whether you're preparing for a job interview, building your own mobile app, or simply aiming to master JavaScript, this course will help you with the tools, confidence, and expertise to achieve your goals. Level up your career with JavaScript Pro. Enroll today on StevenCodeCraft.com and let's take your skills to the next level. In this video, I will guide you through the resources and materials that will help you get the most out of your learning experience on StevenCodeCraft.com. And then we will set up your development environment. So after you create an account, go to the My Courses page and click on the JavaScript Pro course. So if I scroll down here and click Start Learning, this will navigate to the course dashboard. So here on the course dashboard, you can see a button that says to start the video course. And if we scroll down, we can also see links for the course materials. So let's first click into the video course so we can see that interface. So on the left, we see the videos. So here, if I select this particular video, if I scroll down, we can see the different sections. Now, I'll press play to start the video course. So I'll pause it for now and let's look at the different options that we have. So we have an option to show the subtitles. We also have a settings icon where we can adjust the speed. So if the video is going too fast, you can always adjust it. So let's scroll ahead up here. So for each video lesson, I have an active recall study section. So this helps mimic a technical phone screen interview and also helps you understand where you have gaps in your knowledge. So let me play this. So here I will ask an open-ended question. Main focus of object-oriented programming, and how does it organize software design? After I ask it, you'll see this text that says to pause the video and answer. So manually pause the video and try to answer it in your own words. I'll press play again. And then I will provide a sample answer for this question. The main focus of object-oriented programming. So after you hear the answer, don't worry about memorizing it verbatim. It's just to help you understand it in case you struggled with putting in your own words. So after you watch the video, click on the button that says Complete and Continue. So after you do that, you will see a check mark next to this video lesson, and then we'll move on to the next video in the course. So let's go back to My Courses now that you're more familiar with the video section of the course. Let's go back to the dashboard for JavaScript Pro. Now let's discuss the course materials. So scroll down and you see these different links. So for the first link is the code for the course. So this section contains the completed code for the course in a GitHub repository. So this includes the finished projects and examples that we'll be building together. These resources are designed to help you see the end goal and provide a reference for what your own code should look like as you progress. You can use this code as a guide to troubleshoot and refine your own projects. But remember, the real learning happens when you write the code yourself. There's also another link for the starter files. So these files are neatly organized into folders with clear naming conventions to match each video in the course. So we'll click into one of these folders, in this case, the object section. And here you can see different files corresponding to each video lesson. So you can click on this green button. You could either clone the project from your terminal or click on Download Zip. And you can open that in VS Code. There's also an eBook in the course section. And this is a 600-page comprehensive eBook. And it covers all the topics that we'll discuss in the video lessons. So I strongly encourage you to read the relevant section of the ebook before watching the associated video. I'll scroll down here so you're more familiar with what the ebook looks like. So here we have the introduction, and a discussion of object-oriented programming. So reading the material ahead of time primes your brain for what's coming in the video, making it easier to follow along and retain the information. There's one more ebook in the course materials, which is the Active Recall Study Questions. So this is to ensure that you solidify your knowledge and prepare for real-world applications and technical phone screen interviews. So this PDF contains all of the Active Recall Study questions that we will go over in the videos. And this is to test your understanding of key concepts and build a solid foundation in JavaScript programming. Let's scroll here so you're more familiar with what it looks like. So these are all the questions for section 2. So you go through each of these and try to answer it in your own words. And don't worry about memorizing it verbatim of the answer that I provide. Then you can scroll down. So if you struggle with answering that, I provide a sample answer. So I highly recommend that you take the time to answer these questions. Even if you're unsure about an answer, the process of thinking about it and putting in your own words will strengthen your understanding. And of course, you can always refer back to the ebook or the video for clarification. These course materials are here to support you every step of the way. By engaging with them, which includes the finished code, the starter files, the ebook, and the study questions, you'll set yourself up for success and gain a deep, lasting understanding of JavaScript. To start programming in JavaScript, there are two essential tools you'll need to install, Node.js and Visual Studio Code. So what is Node.js? This is a powerful runtime environment that lets you run JavaScript outside the confines of a web browser. It's what enables you to build and run JavaScript applications on your computer, including server-side projects. While you could just run JavaScript in your browser, for this course we will be using Node.js to execute our programs. The second tool is Visual Studio Code, otherwise known as VS Code. Developed by Microsoft, this is an integrated development environment, or IDE for short, and this is where you'll spend most of your time writing, testing, debugging, and running your code. It's a versatile desktop application used by developers worldwide, and we'll be using it throughout this course. Both Node.js and Visual Studio are free and easy to install. Installing Node.js. Begin by opening your browser and heading to nodejs.org. Once you're on the site, click to download Node.js. LTS stands for long-term support. Downloading this version is recommended for most users because it's the most stable and well-supported version of Node.js. Once downloaded, open the installer and follow the on-screen instructions. The default settings are suitable for most users, so you can proceed with them unless you have specific preferences. Installing Visual Studio Code. Next, we'll install our IDE. Navigate to code.visualstudio.com in your web browser. Click the download button for your operating system. VS Code is available for Windows, Mac, and Linux. After downloading, run the installer. Like with Node.js, the default installation options will work perfectly for our purposes. So now once you have installed both Node.js and Visual Studio Code, click to open up VS Code. After you click it, you will see the welcome page. Then open up Finder or File Explorer for your Windows and create a new folder. Now this will be the folder where we place our code. So I'll just name it Project. Now, the name of the folder doesn't matter. Then I can click and drag it into VS Code. This will open up the project. Now to add a new file to our project, I can click on this icon, and I can name it code.js. So the name of this file doesn't matter, but the file extension does. So now we can write our first line of code, and I'll say console.log. Then in single quotes, I'll say hello world. And then I'll end it with a semicolon. Notice as I'm typing, this file has not been saved yet, and so I see a circle indicating that I have unsaved changes. So to save it, I can do Command S, or on Windows it would be Control S. So now if I want to actually execute this file, I can do File, Appearance, and then Panel to open up the integrated terminal in VS Code. Now there's also a shortcut. I can do Control and backtick. So if you don't use the backtick character often, it's located on the left-hand side of your keyboard above the Tab key. So I can do Control and backtick to toggle this open. So I'll be using Node to execute this program. So I'll type Node, and then the name of our file, which is code.js. So here we see this value, hello world, is logged to the console. So I'll close this. Now VS Code offers a lot of features and a lot of ways to customize it. Before this course, we'll just be covering the basics that you need to get started. So on the left-hand side is the activity bar, where we see a list of icons. The topmost icon is the folder icon, and we can use it to toggle our project to see the folders and files within it. Next is the search icon, and we can use this to search, find, and replace text. So for example, let's say if I do hello, and enter, we see that this text is found in our code.js file. So I'll close that. The next one is our source code icon, and this is used to keep track of the changes in our project, as well as collaborate with other developers using Git version control. Next is the run and debug icon. You would use this when setting breakpoints in your code and debugging it if there are errors. Next is the extensions icon. This gives you access to the extensions marketplace. So this enables you to install additional features to VS Code to improve your productivity and help you customize VS Code to your needs. Now the icons on the bottom is for your account, and to adjust your settings. Now on the bottom of the screen is the status bar here in blue. On the left side, you will see any errors or warnings in your code. And on the right side, I see the line number that I'm on for my current file, and I also see the programming language being used. So let's say if I wanted to add another file to my project, rather than always having to click on this icon, I can use the keyboard shortcut of Command and N or Control and N on Windows, open up a new file. And on the bottom right, we see that this is identified as plain text. So now if I want to save this file as a JavaScript file, I can do Command S and I can name it as secondprogram.js. And now on the bottom right, we see that VS Code can identify that this is a JavaScript file. The next thing I want to cover is the command palette. You can access the command palette by going to View, and then Command Palette. Now another way to do that is with the keyboard shortcut of Command, Shift, and P, or it'll be Control, Shift, and P on Windows. Now the Command Palette is very important as it is the control center for all commands in VS Code. From here, we can also adjust the color theme that we use. So I click on Color Theme, and as I scroll up and down, we can see different color themes from my code editor. You can also access additional themes by going to the very top and clicking on Browse Additional Color Themes, allowing you to search through different options. Now for this course, I'll just stick to the standard Visual Studio one. Now to make the text larger, you can do Command and plus or Control and plus on Windows, and also Command minus or Control minus in order to make the text smaller. So this is a quick overview of VS Code, teaching you the basics that you need for this course. So for this course, there are 2 VS Code extensions that I suggest and that we will be using throughout this course. So click on the icon for extensions and type in Live Server. Then you can install this extension, and we'll utilize it later in the course. Now, this extension, Live Server, essentially makes it easy for us to have hot reloading, so when we write our code, we can actually see those changes reflected in a web browser. Then another extension that we'll be using for the early part of this course is Quokka. So type in Quokka. So select this one and then install it. Essentially, this allows us to see the output of our JavaScript without having to constantly run it in our terminal. Before we get started, if you're interested in supporting my courses and projects, you can follow me on my new YouTube channel and Instagram at StevenCodeCraft. You can also explore my courses at StevenCodeCraft.com. And if you're looking to enhance your health and fitness routine, check out my workout and meal planning app at FitFuelPlanner.com. The app offers over 100 recipes, workout plans, meal plans, and a grocery list feature. It's designed to make tracking your calories and macronutrients straightforward and stress-free. I appreciate your support, and I'll see you in the next section. Object-Oriented Programming, or OOP, is a programming paradigm built around the concept of objects. At its core, OOP organizes software design around data, or objects, rather than focusing solely on functions and logic. Objects are instances of classes, which serve as blueprints for creating and managing data and behavior. A class can encapsulate both the data, often referred to as attributes, and the functions, known as methods, that operate on that data. This combination makes it easier to group related functionality and data into a single modular structure. One of the key benefits of OOP is how it promotes modularity and code reusability. By designing software in a way that mirrors real-world objects and their interactions, OOP helps developers create systems that are easier to understand, maintain, and extend. Languages like JavaScript, Python, Java, and C# are just a few examples of programming languages that support OOP, providing the tools to create and manipulate objects effectively. OOP is especially useful for managing the complexity of large software projects, making it a preferred approach for many modern applications. What does object-oriented programming focus on, and how is it different from just using functions? Object-oriented programming, also referred to as OOP, focuses on organizing code around objects, which represent data and the actions that can be performed on that data. This is different from just using functions, where the focus is primarily on writing step-by-step instructions or logic to solve problems, without grouping data and behavior together. Object-oriented programming, or OOP, is a programming paradigm that focuses on objects rather than functions. This approach organizes software design by grouping related data and behavior into self-contained units called objects. At the heart of OOP are its four foundational principles. I'll explain each of these principles up front so you're familiar with them as we begin. Throughout the course, you'll see examples that clarify these abstract ideas. So these four principles include abstraction, polymorphism, inheritance, and encapsulation. First, let's discuss abstraction. Abstraction involves hiding the complex implementation details of an object and exposing only what's necessary. This simplifies how we work with objects, allowing us to focus on their functionality without needing to understand all the intricate details behind the scenes. Polymorphism. Polymorphism means many forms, and this allows objects to be treated as instances of their parent class rather than their specific class. This enables methods to behave differently depending on the object that's calling them, making your code more flexible and adaptive. Inheritance. Inheritance allows new objects or classes to take on properties and behaviors of existing ones. This reduces code duplication and promotes reusability and makes it easier to maintain consistent design across your application. Encapsulation. Encapsulation combines data and the methods that manipulate it into a single, self-contained unit, referred to as an object. By restricting direct access to this data, encapsulation ensures better control, security, and reduces the risk of unintended interference. These four principles, abstraction, polymorphism, inheritance, and encapsulation, can be remembered using the acronym API. Transitioning from procedural programming. Before OOP became widely adopted, many programs were written using procedural programming. This approach divides the program into functions that operate on variables. While simple, procedural programming can create significant challenges as projects grow, such as code duplication and interdependencies. So code duplication refers to repeatedly copying and pasting similar code across functions, leading to redundancy. Interdependencies refers to changes in one function can inadvertently break others, creating a web of interconnected issues, often referred to as spaghetti code. Object-oriented programming addresses these issues by bundling related data and behavior into objects. Within an object, variables are known as properties, and functions are called methods. Why OOP matters. By adopting OOP principles, you can write more modular, maintainable, and scalable code. OOP simplifies interactions between different parts of your application, reduces the risk of errors, and makes your code easier to extend and adapt to future requirements. Whether you're managing a small script or a complex system, OOP provides the structure and clarity needed for professional software development. This lesson provided a high-level overview of the four core principles of OOP, which can be remembered using the acronym API, standing for Abstraction, Polymorphism, Inheritance, and Encapsulation. Throughout this course, we'll explore more practical examples of each of these foundational principles in detail. What is the main focus of object-oriented programming, and how does it organize software design? The main focus of object-oriented programming, also referred to as OOP, is on objects, which group related data and behavior into a single unit. This helps organize software design by bundling properties and methods together, making code easier to manage, understand, and reuse. What is abstraction in OOP, and how does it simplify working with objects? Abstraction in OOP means hiding the complex details of how something works and only showing what is necessary. It simplifies working with objects by letting you use their functionality without needing to understand all the behind-the-scenes implementation. How does polymorphism make code more flexible and adaptable in OOP? Polymorphism makes code more flexible and adaptable by allowing the same method or function to work in different ways depending on the object it is used with. This reduces the need for repetitive code and makes it easier to handle different types of objects in a consistent way. What is inheritance in OOP, and how does it help reduce code duplication? Inheritance in OOP is a way for one class to use the properties and methods of another class. This helps reduce code duplication by allowing you to reuse existing code in new classes instead of writing it again. What does encapsulation do in OOP, and why is it important for control and security? Encapsulation in OOP bundles data and the methods that work on it into a single unit called an object, and it restricts direct access to the data. This is important for control and security because it ensures that data is only modified in controlled ways, reducing errors and preventing unintended interference. How does OOP address the challenges of procedural programming, such as code duplication and interdependencies? OOP addresses challenges like code duplication and interdependencies by organizing code into objects that combine data and behavior. This reduces redundancy by reusing code through inheritance and makes programs easier to manage by keeping related functionality within self-contained objects, reducing the risk of unintended interactions between parts of the program. In JavaScript, an object can be defined using curly braces, which signify an object literal. An object literal is a way to organize data using key-value pairs. So here's you can declare an empty object. So we can use the let keyword, and I'll name the object programmer. Let's assign this to an object literal. I'll give it a key of name and the value of my name. I'll add another key for preferred language, and I'll set that to JavaScript. Now I'll define a method which will utilize these two properties. So I'll name this writeCode and set that to an anonymous function. So this will console.log, use a template string, this.name, writes, this.preferred language, code. And I'll end it with a semicolon. Now I'll define another method, and I'll use syntactic sugar for cleaner syntax. So I'll say drink coffee, then open and closing parentheses. Then I will console log this.name drinks coffee. So this shows different syntaxes that you can use to define methods within an object literal. And I will end this with a semicolon. Now I can call programmer.writeCode. Control and backtick to bring up the terminal. Let's navigate to where this file is. So it is in objects. And here I'll do node, and I'll name this file 3objectliterals.js. And here I see it logged these property values. So in this instance, the programmer object literal has 4 members. So it has 2 properties, the name and the preferred language, and it has 2 methods, writeCode and drink coffee. So this structure allows us to encapsulate related properties and functions within a single organized entity, making our code cleaner and more intuitive to work with. By leveraging object literals, you can create versatile and reusable code structures that represent real-world entities or complex data models effectively. What is an object literal, and how would you create one? An object literal is a data structure in JavaScript that allows you to define key-value pairs. It essentially enables you to group together variables and functions. In the context of an object, it will be referred to as properties and methods, and you would create one by using curly braces. To help reinforce this concept, your exercise is to create a simple JavaScript object literal representing a grocery list item. This object should have the properties of quantity and name, along with a method display that logs the quantity and the name to the console in this format. So to demonstrate how you can implement this, I can use the const keyword, and I'll name it grocery item. You could assign that to an object literal with the key of name. I'll just set that to apples. And the key of quantity, I'll set that to 4. And our method, so that will be display console.log backticks. So I'll say this.quantity times this.name. End it with a semicolon, and we'll close our object literal with a semicolon. Then I can call grocery item.display. Or I can just log this out, and I see the expected output. So suppose you need to add another programmer to your team. Using the object literal syntax repeatedly can lead to duplicated code, which makes your application harder to maintain. This is especially true for objects that include methods, indicating that the object has behavior which may be repeated across multiple instances. So let's consider this object literal that we created in the previous lesson. If we need to create multiple programmer objects, it will be inefficient and error-prone to copy and duplicate all this. So a more scalable solution is to use a factory function. So a factory function is a function that returns a new object each time it is called, ensuring that each object has its unique properties but shares the same methods. So here's how you can implement it. If I name it function, and I will name it createProgrammer. So now we'll specify 2 parameter variables. The first will be name, and the second will be preferred language. Then we'll return an object literal. We'll do name, preferred language. We'll do write code for the method. And we can just copy this. Then the other method is drink coffee. And once again, we'll just copy this console log statement. And since it's a function, we don't have to end it with a semicolon. So we can now create a new programmer simply by calling this function. So I'll scroll down so we can see it. I'll say const new programmer is equal to createProgrammer, pass in the name Alice, and JavaScript as the preferred language. So now, when I call new programmer dot write code, let's pull up the panel, and I'll scroll down. I will list it out, and so I'll do node. I'll just copy the name of this file, and I'll output it. And here we see Alice writes JavaScript code. So using factory functions in this way helps avoid code duplication and simplifies maintenance, making your code base cleaner and more manageable. What are factory functions and why would you use them? Factory functions provide an efficient way for us to create a new object. So the name of the function will be in camel case notation, and it can accept parameter variables. These parameter variables can help customize the values of the object being returned. The benefit is that it reduces code duplication and the need to copy and paste. Create a factory function which returns a new groceryless item. The parameters should be name and quantity. So this is the groceryless item, which we created in the previous lesson. So rather than having to duplicate this, we'll create our factory function. So I'll say create grocery item, and this accepts name and quantity as parameter variables. This returns a new object literal. It'll be name, quantity, and for the method, we can just copy this and paste it here. We can end this with a semicolon. And so now if we wanted to create a new item, we can say const new item is equal to create grocery item. We'll say bananas, end it with the S, and we'll just say 5. So I'll scroll down. We can call new item dot display. So let's bring up the terminal, and I'll run it again. And here we see the quantity of 5 bananas. In traditional JavaScript, there are no native classes as found in languages like Java or C#. Instead, JavaScript uses functions and the new keyword to mimic class-like behavior which is a technique known as constructor functions. This approach was the standard before ES6 introduced class syntax as syntactic sugar to simplify object creation and inheritance. We will cover ES6 and that syntax later in the course, but for now, here's an example of a constructor function for creating programmer objects. So, here I'll just write a comment to say the lesson, and we'll start up Quokka, so we'll bring up the command palette with Command-Shift and P, or Control-Shift and P, and I will say Quokka start on current file. So if you don't see this, just type in Quokka, select that. So now we can see it in our output without having to run node in the terminal. So use the function keyword, and we'll use Pascal case for naming our constructor function. And it accepts two parameters, which is the name and the preferred language of the programmer. Language. Then I'll use the this keyword, which means this current object. Set it to the name, then the preferred language. Now let's implement our methods. So this dot write code is set to the anonymous function, console.log, backticks for our template string, and I'll say this dot name writes this dot preferred language code. We'll end this with a semicolon and the anonymous function. Then I'll say this dot drinks coffee, set that to anonymous function, console.log. I'll say this dot name drinks coffee. Just to demonstrate the syntax. Now, to create an instance of this object and to call this constructor function, we use the new keyword. So I'll say const new programmer equal to new programmer. Then we pass in our arguments. I'll pass in Alice for the name and on JavaScript as the preferred language. Now I can call new programmer dot write code. Save that. And here we see the output. Alice writes JavaScript code. What is a constructor function? A constructor function is used to instantiate a new object in JavaScript. So for the naming convention, you would name the function using Pascal case, and for assigning the properties and for the methods, you would use the this keyword, which references this object or the current object. So now for the exercise, create a constructor function for the grocery item. So to implement that, once again, we use our function keyword and we use Pascal case. So the first character of each word is capitalized. This takes in two parameters, the name and the quantity. Or this keyword with this object, just assign this to the quantity. Now for our display method, this.display, set that to an anonymous function, console.log, backticks, this.quantity times this.name. End that with a semicolon. So now we'll create an instance of the grocery item, and we call this constructor function with the new keyword. So I'll say const new item is equal to new grocery item. For the name, we'll say bananas and the quantity of 5. So now let's call this display method. So that'll be new item dot display. Save that. And here we see the output, which is 5 bananas. Every object in JavaScript includes a special property known as constructor. This property references the function that was used to create the object via the new keyword. For instance, we consider our constructor function for a programmer object. Here we use the new keyword to call this function. So if we wanted to find out which constructor function created this object, we can access that via its constructor property. So let's console log that. So I'll say new programmer dot constructor. Now when we log that in the console, so this file is named Constructor Property.js. So this will output the programmer function, confirming that new programmer is an instance of this programmer constructor function. So this property is particularly useful for confirming the type of object you're working with, especially when dealing with complex code bases that involve multiple constructors and prototypes. In JavaScript, functions are treated as objects. This means that like any object, a function can have properties and methods, and it can be assigned to variables or passed as arguments to other functions. So let's consider a simple function. If I just name it add, and it takes in two numbers, num1 and num2, and it simply returns the sum of these values. So you can assign this function to another variable, effectively creating a reference to the original function. So if I were to do const, if I just name this n, and assign that to add, now n will reference this function, as functions are objects in JavaScript. So now I can actually call that function console.log with this reference, n. So I can say n, I can pass in 2 and 2, so I'll expect the output of 4. So starting up Quokka, I see that the output is 4. So as an object, the function add has properties and methods. For example, the length property of a function returns the number of its expected arguments. So if I were to do console.log of add.length, we get the value 2, as there are two parameter variables. So to further illustrate how functions are objects, consider creating a function using the function constructor. So I can name that with const programmer func equal to new function, taking in the name, and I'll use backticks. So this.name is assigned to name, and I'll define a method, write code, assigned to an anonymous function, console.log, code in JavaScript. So let's instantiate an instance. So I can say const, and I'll just call this programmer, is assigned to new programmer func, and I'll pass in my name as the argument. So now let's call this method, write code, programmer.write code, and here we see our expected output. So this lesson shows the unique nature of functions in JavaScript. By understanding that functions are indeed objects, you gain a deeper understanding into the flexibility and capabilities of JavaScript as a programming language. So for your exercise, create a function named calculatePrice. So this function will accept two parameters, a grocery item object and a price, which is just a number. So in that function, simply return the price times the quantity of the grocery item. So based on our previous lesson, we created this constructor function to create a grocery item, and we instantiated a new item. So we want to create the function calculatePrice, which accepts a grocery item and a price, and we simply return the price times grocery item quantity. So we want to assign this function name to a variable to demonstrate that functions are objects in JavaScript. So we can do const perform calculation is assigned to calculatePrice. So now we can invoke it with this reference. So let's do console.log perform calculation. So for the first argument, we'll pass our grocery item, and we'll pass 25 cents. So here we see the output in Quokka is 125. JavaScript supports 8 different data types, which include 7 primitive types and 1 complex type. The primitive types are number, string, boolean, big int, undefined, null, and symbol. The 8th data type is object, which also encompasses arrays and functions. Understanding the distinction between these types is crucial due to how they are allocated and managed in memory. So to demonstrate primitive types, these are passed by value. So when you work with primitive values, these are passed by copy. So this means if you assign a variable to another containing a primitive value, the new variable gets a copy of that value. So altering one will not affect the other because each variable holds its own unique value in a separate memory location. So if I instantiate, let A, initialize that to the value of 10, and I initialize B, and I assign that to A, B will get a copy. So they are not referencing the same data in memory. So if I do A, and I reassign that to 20, let's start Quokka. Console log this, console log the value of A, and we'll console log the value of B. Here we see they are different values. So now, let's consider reference types, which are passed by reference. So on the other hand, reference types, like objects, are handled differently. So they are passed by reference, meaning both variables point to the same object in memory. Thus, changes made in one variable are reflected in the other. So, say if I assign A, and assign it to an object with the value of 20, then if I assign B to A, they now reference the same object in memory. So if I update A.value to be 100, this will be reflected in both of the references. So let me just copy these console log statements and output them. Here we see they are referencing the same object. So in JavaScript, primitive values are copied by value, meaning they do not affect one another when changed. Now objects, which include arrays and functions, are copied by reference, meaning changes to one affect any other variable referencing the same object. This fundamental understanding helps in managing how data is passed around in your programs, ensuring fewer surprises and more predictable code behavior. What are primitive values and what do they pass by? Primitive values refer to simple values, such as string, number, or booleans, and they are passed by copy. What are object values and what do they pass by? Object values refers to key value pairs. This also includes arrays, and they are passed by reference. So objects in JavaScript are inherently dynamic, which means that you can add or modify their properties and methods at any time after their creation. Using the const keyword with an object declaration ensures that the variable cannot be reassigned to a different value. However, the contents of the object it points to, such as its properties and methods, can still be altered or extended. So consider the following example. If I instantiate a person object, and I give it the key of name and the value of my name, let's end it with the semicolon. Now if I console log this, console.log of person. Now let's start up Quokka. So bring up our command palette, start on current file. Here we see it just outputs our object. Now, if we want to add properties, we can do so using either dot notation or square bracket notation. So if I use dot notation first, I can say person dot favorite food. Just assign that to tacos. And I'll just copy this console log and we'll output it just to demonstrate that I have dynamically added this property. Favorite food. And here we see this contains the two properties for the name and favorite food. Now, let's use the other syntax, which is the square bracket syntax. And I'll call this favorite ice cream. And let's just assign that to chocolate. Now let's paste our console log statement. And here we see our object has been updated. Now we can also use the delete keyword, which will delete a property. So if I do delete person.favorite ice cream, and let's paste this again. And here we see our object has been updated dynamically again, deleting the property of favorite ice cream. Now let's add a method. So I can say person.eat. Let's assign this to an anonymous function. Here, I'll say console.log with backticks, and I can say this.name eats this.favorite food. And then with the semicolon. So now let's invoke this method that we've added dynamically. So I'll say person.eat, save that. And if I look here, let me expand this. We see Steven eats tacos is the output. So this ability to modify objects is both powerful and flexible, allowing us to adapt objects to changing requirements or conditions dynamically. However, it also means that you need to manage objects carefully to avoid unintended side effects from these changes. Explain in your own words, how are objects dynamic? Objects in JavaScript are dynamic because you can change and mutate the properties and methods of the object after it has been initialized. So for your exercise, create an object with the grocery item constructor function. Then dynamically add the property of grocery aisle. So here we have this grocery item constructor function. Let's instantiate an instance of it. So we can do that with const new item. We'll call the new keyword grocery item. We'll name this bananas with a quantity of 5. Now we want to dynamically add a new property. So I can say new item dot grocery aisle, and I'll set this to the produce section. Now let's just console log this, console.log of a new item. And here we see we have dynamically added the property of grocery aisle. In JavaScript, different loops offer various ways to iterate over collections like arrays and objects. For arrays, we can use the for-of loop. So the for-of loop is ideal for iterating over array elements. So if we do let numbers, and I assign this to an array of 1, 2, 3, 4, and 5, then if I just do for const element of numbers, then console.log of element, here we see the output is just each of these elements. Now for objects, we can use the for-in loop. So the for-in loop allows you to iterate over the keys of an object. And this is useful for accessing values when you know the structure of the object. So I can do const dog and instantiate this object with the name of Max, the age of 5, and so the eye color of blue. We'll end this with a semicolon. Now we can use our for-in loop, so for, and I can say const key in the dog object. Now I can do console.log of dog and access the key with square bracket notation. And here I see this will output the associated values for each of the keys. So besides these two traditional loops, JavaScript provides methods to retrieve the keys, values, and key value pairs directly from objects, which can be iterated over with the for-of loop. So let's say if I want to get the keys, I can do const keys equal to object.keys of the dog object. So now, if I do const key of keys, I can do console.log of key, and here this will output all the keys of this object. Likewise, I can do the same with the values. So const values equal to object.values of the dog object. Now for const value of values, console.log each of the values. So now this outputs the associated values. Now we can also enumerate over the key value pairs with object.entries. So I can do const entries of object.entries, pass this object in. Now I can do for const entry of entries. Now here I can do console.log. And I'll use backticks because I'm going to use interpolation. The key, if I can access at the first index, so that'll be index of 0, and the associated value, which would be entry, at the index of 1. So we can save this. And so the object is supposed to be dog as our object. So here are the outputs, the associated key value pairs for each of the properties in the dog object. So these methods provide a powerful and flexible way to handle objects in JavaScript. They simplify the process of working with object properties and makes your code cleaner and more efficient. How can you enumerate over the properties of an object? There are different ways to enumerate over the properties of an object. One way is you can use the for-in loop to iterate over the keys of an object. We can also use the built-in object class. For example, iterating over the keys with object.keys, enumerating over the values with object.values, and enumerating over the properties with object.entries. So for your exercise, write 3 for loops enumerating over the object's keys, the object's values, and the object's key value entries. So to complete that, let's enumerate over the object's keys. We can do that with for, I can say const key of object.keys. And for the argument, I'll pass in this object that we created. Then we can console log the key. So here we get all the keys for the object that we enumerate over. Now we can loop over all the values. So I can say const value of object.values, passing a new item. And here we'll just console log the value. So here we get the associated values that we passed in as arguments when we first instantiated this object. So now let's enumerate over the key value entries. So I can say for const entry of object.entries, new item. So now we can do console.log. We'll just log out entry. So here we see each entry is an array where the value at the 0th index is the key and the value at the first index is the associated value. Abstraction is a core concept in object-oriented programming that involves hiding complex details while exposing only the necessary parts of a class or object to the user. This makes the objects in our applications easier to interact with and reduces the impact of changes. So let's consider the programmer constructor function that we've been using, and I'll illustrate the concept of abstraction. So we use the function keyword, and I use Pascal naming convention to name our constructor function. The parameters are name and preferred language. So now we use the this keyword to assign our properties, and we will assign our preferred language. So now that we've assigned those properties, let's create a public method. Just create a comment just to illustrate that. So we use the this keyword to create our public method, and I'll name it writeCode. We assign this to an anonymous function. Now I'll use a keyboard shortcut, so I can just type out log. And so here VS Code says log to the console, so I can press tab for auto-completion. So now I'll use backticks, because I want to use string interpolation. So $, and then curly braces, this.name. So I'm utilizing this property in our string, writes this.preferred language code. So this public method is accessible through dot notation when we create an instance of this programmer. So now, to demonstrate a private method, so the concept of abstraction refers to using private methods such that the public methods are only those that are absolutely necessary, and we want to abstract away the details. So I can use the const keyword. I can also use the let keyword. So if you recall, both the let keyword and the const keyword are only available within the block that they are defined in. Right? So you can only call it within the block that it's implemented in. So I assign this to an anonymous function. So we'll use our keyboard shortcut again with log, and then down arrow, and then tab. And once again, I'll use backticks and use interpolation. So this.name drinks coffee. So now let's define another public method. And now we will utilize this private method that we defined. So I'll use the this keyword, and I'll assign this to an anonymous function. And here I will just call our private method. So here we see with abstraction, we are abstracting away the implementation details, which is hidden from the user. So to better illustrate this, I can create an instance of this programmer. So I can say const programmer. I'll use the new keyword, which calls this constructor function, and we named it programmer. So I'll say name, Steven, and preferred language is JavaScript. So now if I do programmer dot Here I can see what is accessible through dot notation, or what its public interface is. So here I see the name property, I see the preferred language, and I see the public methods of start day and write code. So let's call write code, and I'll just do Shift, Option, and down arrow to create a copy, and I'll try to call drink coffee. So here I'm attempting to call this private method. Let's see what happens. I'll save it with Command S. Now I'm going to bring up the terminal. So I'm going to do Command and J for that. So here I've already navigated to the directory where this file is located. And I named this file 11-abstraction.js, but your file could be named differently. And here I'll just run it in the terminal rather than using Quokka to better illustrate this. So 11-abstraction.js. So here when we run it, if I scroll up, when I called write code, this outputs this .name writes preferred language code. And so here we see the output is Steven writes JavaScript code. So that worked as expected. However, here we see we try to call this private method, and we get a type error that programmer.drinkcoffee is not a function. So we know it's not accessible, and this is what will occur if we try to call a private method. So it will throw an exception. So now, we want to instead use the public method. Right, so only public methods are accessible through dot notation. So I'll clear this with Command K, and then up arrow, and we'll run it again. So now I see I get the expected output when I ran write code. However, when I called start day, this called the private method I defined, where we have this .name drinks coffee. And here we saw the output of undefined drinks coffee. So this means that this .name is currently undefined within this context. So if you remember in JavaScript, functions are objects and they have their own this context. So in this instance, or this example rather, this is referring to the function that is defined in. However, we want the this keyword to instead reference its enclosing scope. So the enclosing programmer, such that we can access this .name. So in order to do that, we can use the bind method. So I can say .bind, and I'll say this, which references the current context that it's being implemented in. So that constructor function. So now if I run it again, let me clear this with Command K, up arrow, and then run. And here I see the expected result for this private method, call in start day, which is Steven drinks coffee. So that is the result of calling this method. So to recap, in this example, we saw that, let me close the terminal so you can actually see it. Write code is a public method that is accessible to any instances of this programmer constructor function. And on the other hand, drink coffee is defined as a private method inside the constructor function, and here we use the const keyword. So this method is not accessible from outside this code block, so outside the programmer function. Instead, it is meant to be used internally by other methods within the programmer object, like start day, here, which exposes a controlled interaction with drink coffee. So this illustrates the concept of abstraction, which is utilizing private methods and hiding away the implementation details. So some key points on abstraction that I want to discuss. Two main points. One is you just want to show what is necessary in the public interface. So in our example here, we see that start day, that method abstracts away the details of what starting the day entails for a programmer. So in this case, drinking coffee. Now, the consumer of this programmer constructor function does not need to know the implementation details. They just need to know that they can start the day and call that public method. The second point of abstraction is hiding the complexity. So methods like drink coffee do not need to be exposed outside of this object as they handle specific functionalities and implementation details that are not relevant to the programmer that is utilizing this constructor function. So this approach helps in maintaining a cleaner interface for the objects, making them easier to use, and reducing dependencies on the internal implementation details. So we can always change those implementation details in the future and minimize the impact of those changes. So this leads to better modularity and easier maintenance of our code. So in this exercise, we will build upon the grocery item constructor function that we've been using in previous exercises, and we will create a grocery list constructor function. So this will help us understand the concept of abstraction, which involves hiding the implementation details and exposing only the necessary parts. So here is the initial grocery item constructor function. So the grocery list constructor function should internally maintain an array to store grocery items. It should also provide methods to add items, display all items, and get the total quantity of items. So to practice abstraction, we will use private methods for operations that should not be exposed directly. Specifically, you will implement a private method for calculating the total quantity of items. So here's a starting point for the grocery list constructor function. Use the function keyword. We'll name it grocery list. This doesn't accept any parameters for the constructor function. Then internally, we have items, which will hold the grocery items. I'll just add a comment, private array to store items. Your task is to complete the grocery list constructor function by adding the following methods. You will implement add item, which accepts two parameters for a name and quantity, and this adds a new grocery item to the list. There is display items, which will display all items in the list. There is get total quantity, which will return the total quantity of all items. And we have a private method, calculate total quantity, to calculate the total quantity of items. So by the end of this exercise, you will have a better understanding of how to implement abstraction in JavaScript using constructor functions. So now let's implement our grocery list constructor function. I'll scroll down so we have more room. So now, first let's implement our private method to calculate the total quantity of items. So, you can use the const keyword, and I'll name this. And we'll name this calculate total quantity. We assign this to an anonymous function. Now we will return this quantity, and we'll utilize the reduce method that's built in for the array data type. So items.reduce. So with this, we can take all the items in our list and reduce it to one value. So here we pass our callback function. So the previous value, which we can name that total, and the current value, so I'll name that item. We use our arrow function syntax. So the total plus the item dot quantity. Right, so here for our grocery list, we have the properties of name and quantity. Now for the reduce method, it also takes an optional second parameter, set that to 0, and this represents the initial starting value. So now I've implemented that. I'll just add a comment here, just so we know that it is a private method. So now we will implement our other methods needed to operate on the grocery list array. This.add item, so an anonymous function, takes in the name and a quantity. So now let's create that new object. So const item, and then new grocery item. So let's pass in these arguments to create the new object, and then we will add it to our items array. So now we'll implement our display items method, assign this to an anonymous function, and we can do items, and here we can call the built-in for each method. So it would be the item, so the current item that we are operating on, and we simply want to call the display method. So the display method we have implemented here, and here this console logs the quantity and the name of the item. So we can implement all this on one line. So now, we want to implement get total quantity, set this to an anonymous function, and we simply will call this private method that we have implemented here. So now let's utilize this grocery list constructor function. So I'll say const, I'll name it my list, and we'll use the new keyword then grocery list, and this doesn't accept any arguments. So now that we've created a list, let's add items to it. So mylist.add item. So I'll say banana, and a quantity of 5. Then just to copy this, I'll do Shift Option and then down arrow. I'll just rename it to be apple. And let's say the quantity is 3. Let me scroll down so you can see. So now let's call mylist.displayItems. So this will go through and output. So let's bring up the terminal. So Command and J or Control and backtick. So I'll do up arrow and then I'll run it. So here I see when I call display items, this outputs the quantity and the item name for all the items in our list. So now I'll comment this out and I'll close the terminal just so we can see better. Now I want to console log. I'll use backticks. Now I want to find the total quantity of items in our grocery list. So total quantity. We use interpolation here. So mylist.get total quantity. So we're calling that public method. End it with a semicolon. So once again, we'll open up the integrated terminal. So Command and J or Control and J. Up arrow. And we'll run it again. And here we see the total quantity is 8 items in our grocery list. So some key points on abstraction. Once again, we want to show only what is necessary. So only the methods of add item, display items, and get total quantity are exposed to the user. The user does not need to know about how the total quantity is calculated. So that is a private method. And the second key point is hiding the complexity. So if I scroll up again, so the calculated total quantity method is private, and its functionality is the internal implementation details that should not be exposed. Closures in JavaScript are a powerful way to achieve encapsulation, which is one of the core principles of object-oriented programming. So if you remember our acronym of the 4 pillars of object-oriented programming, which is API, so the A is for abstraction, the P is for polymorphism, the I is for inheritance, and the E is for encapsulation. So what is a closure? A closure means that an inner function has access to variables declared in its outer function. This allows you to hide the internal state and functionality of an object, exposing only what is necessary to the outside world. So this is a technique that enables us to achieve encapsulation. So using closures, we can create private properties and private methods, making JavaScript objects easier to work with. So instead of overwhelming the user or object with too many public properties and methods, you only expose what is absolutely necessary for the object to function properly. So let's go over a simple example to better understand the concept of closures. So I use the function keyword, and I'll name this function example. So within it, I'll create a constant named num, and I will initialize it to the value of 5. So now I'm going to create a function within this function. So remember, in JavaScript, functions are objects. So I can name this log num, and here I'll type log, and then I can log to the console, so I get that auto-completion that Visual Studio Code provides for me, and I will log out that identifier of num. So now I will call or invoke log num. So now let's call example. So here we see this inner function has access to the variables declared in its outer scope. So its outer function, which is this constant value. So let me bring up the integrated terminal. I'll do that with Command J. You can do this with Control J. So node, and I name this file 12-private. I'll do tab so it auto-completes for me. So we output that. So here when we invoked, or called this function, example, we get the expected output of 5. This is a simple example demonstrating the concept of closures, where inner functions have access to variables declared in its outer scope. So let's go through a more complex example. In the case when we return the function, so rather than simply defining this function, or declaring it rather, let's instead return it. So we can do return, and we'll delete this. So now this function returns a function. And so when we call example, we want to store the result. I'll name this inner function, initialize to that. And so now lognum is now accessible through inner function, right? So this is referencing the function that is being returned. So now let's call that inner function, and we invoke it. So let's bring up the integrated terminal again. Up arrow, and we're running. And once again, we get the expected result. So even though this function, which we named example, has finished executing, inner function still has access to num because of the closure. So even after this example, right, even after the outer function has finished executing, the inner function is still able to access all the variables and identifiers declared in its parent scope at the time of declaration. Right, so you'll get more practice with this and you'll become more understandable. Let's go over a more complex example, and here we'll create private properties and methods using closures within a constructor function. So, once again, we use the function keyword, and I'll just name this make functions. So here, if we use the let keyword, I'll name this private num, and we'll initialize it to the value of 0. So now we'll create inner function private increment. So this just increments the value, ++. So now we have these local values, which are not accessible outside of this function. And here we will return a JavaScript object, and we will define an interface. Right, so methods to use. So we'll have our lognum method. We'll define this with an arrow function. So we'll do log, and then tab for that auto-completion. This will console log the number. Now, we'll define another method, increment. Once again, we'll use an arrow function to define it, curly braces. So this will call private increment. Here we'll do log, tab, and we'll just say incremented. So now, let's call make function. I'll say const. Now we can destructure these values. So, use curly braces, log num, and increment, make functions. And so this is an example of destructuring. So we know make functions returns an object, and we've destructured these two methods. So now it's easier to work with. Now, if we didn't do destructuring, we could name this, for example, increment object. We could really name it anything. And through increment object, we can access the increment and lognum methods. But I prefer the destructuring syntax. So, the Command Z to get back to that. So now let's call lognum. This will output the value of 0, which it was initialized with. Then we can call increment, which will update the value, and we will see the console log value of incremented. And then we can call lognum again. So let's bring up the integrated terminal again. Here I will scroll down. We'll clear it with Command K, up arrow, and we run it again. So here we see the initial value of private num is 0. We incremented the value, and the updated value is 1. So this shows an example of closures as this make functions has finished executing. But here, this JavaScript object and the methods defined within it still have access to these identifiers or the variables declared in its parent scope. And this helped us achieve encapsulation because we only expose lognum and the increment method, and we're not exposing the inner implementation details or the private num property. So let's clear this out. We'll go through another example. So using closures in a constructor function. So we'll go back and we'll use our example for the programmer constructor function. The parameters are name and preferred language. So I'll just write some comments just so it's easy for us to identify what we're doing. So we'll specify a private property. So we're not going to use the this keyword. So it's not accessible through dot notation. So I'll use the let keyword instead. And we'll assign this to the value of name. Now an example of a public property, which will be accessible through dot notation. So this dot preferred language assigned to that parameter of preferred language. So now let's define a public method. We use the this keyword, say write code, assign this to an anonymous function. Let's do log and a tab for that auto completion. We use backticks, and we can say code in this dot preferred language. Now, an example of our private method again, say let drink coffee, assigned to an anonymous function. Here we will log it again, so log to the console. I'll just say gulp, ... Now we'll say a public method that uses a closure. So this dot start day, assign this to an anonymous function, and we just call drink coffee. So we are hiding those implementation details of this. So let's actually instantiate a new programmer. So we'll say const programmer. We use the new keyword and the name of our constructor function. We'll say Alice, and the language is JavaScript. End this with a semicolon. Now, programmer.write code, and we'll say programmer.start day. Right, so this repetition is really good to help you get used to the syntax, as well as get a better understanding of the terminology that we use in programming. Let's scroll down, open up the integrated terminal, up arrow, and run. So here we see code in JavaScript and gulp. So in these examples, let's close this, and we'll look over our implementation of this constructor function. So private name, let's actually use it. So we can use private name. Right, so let's run it again to make sure that we're actually utilizing our private property. So here we see Alice codes in JavaScript and just gulp. So private name and drink coffee are private because they are defined with the let keyword and not exposed via the this keyword. So considering public properties and methods, preferred language and write code are public because they are defined with the this keyword and can be accessed outside the function and through dot notation once we create an instance of this constructor function, this programmer. So using closures. So the start day method demonstrates a closure. It is a public method that can access the private drink coffee method because of the closure. It can access the variables and the identifiers declared in its outer scope. So let's consider closures versus scope. So scope is the context in which variables and expressions are visible or can be referenced. If a variable is not in the current scope, it is unavailable for use. Now for closures, these are functions that capture and reference external variables. So when I say external variables, this refers to variables which are not defined locally in the function, but these variables are accessible because they exist in the outer environment. The function defined in the closure remembers the environment in which it was created at the time of function declaration. This is why drink coffee, this method, remains accessible only within functions defined in the same scope, so only within the constructor function. So closures are a fundamental and powerful aspect of JavaScript, allowing for more secure and modular code by protecting and encapsulating behavior within objects. So we covered a lot of new terminology in this lesson. I'm not expecting you to remember and know all of it immediately, and we're going to get more practice and more exposure to these concepts throughout the course, so it'll make more sense. The main takeaway that I want you to get from this lesson is that a closure means that an inner function has access to variables declared in its outer function. What are closures? So closures are inner functions that are able to access variables defined in its outer function. So in other words, closure functions can access variables from their outer scope even after the outer function has finished executing. Now you would utilize closures in order to achieve encapsulation and to hide private variables or private properties. So now for your exercise, the objective is for you to understand and implement closures to create private properties and methods within a constructor function. So your task is to create a bank account constructor function that can manage a user's account balance. So the balance should be private, and the constructor should provide public methods to deposit money, withdraw money, and check the balance. So now to go over the instructions. Step 1, you want to define the bank account constructor function. Now it should have a private variable balance to store the account balance. It should have a private method to validate the amount being deposited or withdrawn. So this private method will validate and ensure that the value that you are passing as an argument is of the number data type, and that the amount stored in the balance is greater than the amount being withdrawn, as well as the money that you're depositing is a positive number. So it should have public methods to deposit money, withdraw money, and check the balance. So step 2, you want to implement the following public methods. The first is deposit, which accepts the parameter of the amount to deposit. So this adds the specified amount to the balance if it is valid, right? You're utilizing that private method to validate the argument. The second method, or second public method, is withdraw, which accepts the parameter of the amount, and this subtracts the specified amount from the balance if it's valid and there are sufficient funds. Now the third public method is getBalance, which simply returns the current balance. So pause the video and attempt to implement this constructor function for the bank account. So now that you've attempted to implement that, we'll go ahead and write the code for that. So we use the function keyword. Then, name of it is bank account. Now for the parameter, I'll specify initial balance. Now I'll use this as a private property, so it's not accessible through dot notation. You can only access it through the public interface or the public methods. This helps us achieve encapsulation. So we're setting that to the initial balance. And I'll add a variable just to better describe what I'm doing. So private variable to store balance. Okay. Now I want to implement the private method to validate the amount. So this amount could be what is being used to either deposit money or to withdraw money. So const, and I'll say is valid amount. The anonymous function, parameter being amount. So return. And I'll use the type of operator because I want to ensure that the amount is of the number data type. So and we will check that the amount is greater than 0 because we can't deposit a negative number and we don't want to withdraw a negative number. So we can utilize this helper method in our public methods that we're going to implement. So I'll just say public method to deposit money. So we use the this keyword to create a public method within our constructor function. We'll name it deposit, and we assign this to an anonymous function with the amount being the parameter. Now we're going to utilize our private method. So if is valid amount for the amount, then I'll do curly braces. So in the case when the amount being deposited is the number data type and it is a positive number, then we want to perform that update. So we will use our shorthand syntax to update the balance in the bank account, and we will log it out. So I'll say log, down arrow, and then tab. I'll use backticks. So deposited. Now, colon. Now we're using interpolation, so I'll do a $sign and then curly braces and the amount. Now, because I'm doing US dollars, I want to use the $sign in the actual output. So I'm going to add another $sign before, just so the correct symbol shows up when we output it to the console. So now, else, in the case when it's not a valid amount, so do log, then tab, and then I'll say invalid deposit amount. So I'm informing the user on that. So we've implemented this. I can end that with a semicolon. Now, we want to implement the public method. I'll scroll up so you can actually see better. So, public method to withdraw money. So now we'll do this dot withdraw. We'll assign this to an anonymous function. Now, once again, we're utilizing our helper method. So if is valid amount, making sure that that is a number data type and a positive number. And if the amount that we're trying to withdraw is less than or equal to the balance, then we can actually perform that. So we'll use shorthand syntax to update the balance. So minus equals. And we will log that to the user to inform that this has been successfully performed. Backticks, withdrew, interpolation, the amount, and we want the $sign to show up, so we'll add that there. Else, we'll log, and tab, insufficient funds. Now, in the case when it is not a valid amount, so in the case when the amount that you passed as an argument is either not of the number data type, or is a negative value, then we want to output a message for that case. So I'll say invalid withdraw amount. Okay, so we implemented that. We have one more public method, which is to get the current balance. So once again, we use this keyword, get balance, anonymous function, and then we will simply return the balance. So we're just returning this private property that we set here. So now we've implemented this. I'll scroll up so we can actually utilize it. So now let's instantiate an instance of this and call this constructor function. So I'll use the const keyword. I'll name the identifier my account, and we assign this to new bank account. Now for the initial value, I'll specify 100 as the initial balance. So now I can do my account dot deposit, and I'll deposit 50. Now let's do my account dot withdraw, and I'll withdraw 30. Then we can do console.log, and I'll say my account dot get balance. So let's call it. So now let's open up our integrated terminal. I could do that with Command and J or Control and J. Now I'll do up arrow, and I'll run this. So here we see the correct console logging, where we deposited $50, and then we withdrew $30. And because we started with the initial balance of 100, we get the expected output of 120. So let's close this integrated terminal and then scroll back to the code that we wrote for this exercise. So an explanation of it, we have private properties and private methods. Here, our private property of the balance of the bank account, and the private method, which is the isValidAmount helper method. So the balance variable and the isValidAmount function are private because they are not exposed via the this keyword. Right? We're using the let keyword and the const keyword. So these are accessible within the block that it is defined in. So accessible within the constructor function. Now we have public methods with deposit, withdraw, and get balance. And they're accessible and public methods because they utilize the this keyword. They could be accessed outside of the function through dot notation. Now for using closures, the public methods demonstrate closures in the sense that they can access the private balance variable and the isValidAmount function because they are defined within the same scope. Right? So closures are inner functions that can access identifiers or variables in its outer function. So some key points on closures. First is it helps us achieve encapsulation, where we hide internal state and functionality, exposing only what is necessary. Another key point is scope. So this is the context in which variables and expressions are visible or can be referenced. And to recap on closures, these are functions that can access variables from their outer scope even after the outer function has finished executing. So by completing and attempting this exercise, you have more experience with closures and have a better understanding of how to create private properties and methods to encapsulate the internal state and functionality of objects. Getters and setters are special methods that provide you with a way to get and set the properties of an object. This encapsulation technique allows you to control how important values are accessed and modified in your objects. It's often used to ensure that data encapsulation and validation rules are followed. Here's how you can incorporate getters and setters into the programmer or constructor function using object.defineProperties. So here we have this private property, private name, and we cannot access it through dot notation. So, in order to access that value, we can do object.defineProperties. Now, if I hover my mouse over, that the first parameter is the object where we want to add or modify properties. So I'll use this keyword, which means this current object, or this programmer object. And for the second parameter, I will specify an object. Again, this with a semicolon. And here we'll define the name of the property. So I'll name it name. And then define an object. And here we can use the special keyword for get. And we'll set it to an anonymous function. And this will simply return the private name. So now, if I actually want to use this property, if I've instantiated a programmer object, I can do log, tab, I can say programmer.name. So rather than having to call .get, I simply can access it through a property, and that will call the get method. So let's run this in the integrated terminal. So Command J or Control J, and I name this file 13 getters and setters. So do tab, the autocomplete, and then I'll run it. And here I get the name of the programmer, which I have access through that get method that we defined, right, through that name property, which we defined here. Now we can also set the value. We'll use the keyword for set, and we'll set this to an anonymous function. The parameter will be the new name that we want to set. Now with setters, we can implement validation rules to ensure that the value that we are setting is appropriate. So I can check and make sure that the new name is not falsy, which means that the new name is not an empty string, value null. So in the case when the value that I was setting is falsy, I can log to the console, and I can say the name cannot be empty. And then we will use the return keyword to stop the execution. Otherwise, we will set the private name. So here, say new name. Now let's utilize this setter method. Now we would do this through the name property. If I scroll down here, if I want to set the name, I can say programmer.name, and I'll set it to my name, Steven. Now here, I'll copy this. And here we see the name is changed. So we'll open up the integrated terminal again. Up arrow, and we run it. So here we see I successfully changed the name to be Steven. We're able to accomplish this because of the setter method. Now let's check and make sure that our validation rules apply. So let's say instead of assigning this to my name Steven, let's say if it was an empty string, run it, integrated terminal, clear this out and run it again. Here we see this console log statement saying the name cannot be empty. And then when we log the name again, we see it continues to be Alice, which means that our validation rules were applied. Getters and setters. The name property has a getter and setter defined, and the getter simply returns the current value of the private name, this private property, while the setter allows you to validate the new name before assigning it to private name. So this is an example of encapsulation, utilizing getters and setters, also known as accessors and mutators. And this structure ensures that the internal state of the object, in this case the private name, can only be changed in controlled ways, increasing data integrity and interaction safety. Using getters and setters not only encapsulates the internal state, but also allows for additional logic to be implemented when getting or setting a property, such as validation or logging, which enhances the functionality and robustness of your code. In this section, we covered the fundamentals of object-oriented programming, beginning with a definition of OOP and an exploration of its 4 core pillars. We covered essential concepts and techniques, including object literals, factory functions, and constructor functions, which are foundational in understanding how objects are created and utilized in JavaScript. We also discussed the constructor property, which links an object back to its constructor function, and examine how functions themselves can be treated as objects in JavaScript. This leads to a deeper understanding of JavaScript's flexible approach to OOP. Important distinctions between value and reference types were highlighted, clarifying how JavaScript handles data storage and manipulation, which is crucial for effective memory management and performance. Further, we explored dynamic aspects of objects, such as adding, removing, and enumerating properties, providing practical skills for manipulating object properties in real time. The concept of abstraction was introduced, along with practical implementations of private properties and methods, which enhance encapsulation and data hiding in JavaScript. Finally, the use of getters and setters were discussed, illustrating how these can be employed to control access to an object's properties, ensuring data integrity and encapsulation.